Hello, juniors. That's right, it's me, Mr. Brooks, and we are getting ready to start Chapter 3. This is the first section in Chapter 3. Coming to you from within the bowels of CHS. You hear all kinds of things running behind me and whatnot. Well, that's okay. Don't be feared. But we'll get you through this lesson. Not terribly difficult. All right, we're talking about systems of equations and two variables and an x and a y. And how can I solve that? You did do this as a freshman, and some of the stuff we did in the last chapter hopefully will help you out here. So we'll get rolling here. I'll get the video off so you don't have to actually look at me the whole stinking time. You just have to listen. So, all right, here's how this works. When I write, you write, okay? It's pretty simple, okay? We got a nice notes template here set up by our good friend Mr. Houston, so we'll get through this stuff, all right? Have a good day. Okay, guys, I'm back here with you. First example here, when we have a system of equations, we're dealing with two separate equations. So here is our first equation, and then here's our second one, or x, I like to call it 1x plus 2y, and that equals 8. Here's one thing I like to do. I like to label these. So like this is equation A, this is equation B. When we get further down the road, you'll kind of see why. But in this first example, we just want to figure out, these are two linear equations, keyword being line, okay? What we want to do is, we want to find the solution. And when it says up here in the example, solve a system by graphing. So what we're going to do is we're going to graph this line and this line, and we're going to look for where they intersect, okay? So for example, we got to take equation A, all right? And is he in slope-intercept form? Now, hopefully you're thinking, no. So we need to get him that way. So what we do is we're going to subtract 3x from both sides. So now I'm left with negative 1y equals negative 3x plus 3. And then we got to then divide by negative 1 because you can't have that negative. We divide everything by that negative 1. And so now equation A is going to be y equals a positive 3x, the two negatives make a positive there, minus 3. Now, you should be thinking, yeah, this looks like it's in slope-intercept form, okay? That's what you need to do here, okay? Now, let's go over here, and we got to work out, actually, let's go ahead and graph this. Let's just do this first. So the B, we always do the B first because it's the beginning, is negative 3, and your M is 3 over 1, right? So if we're going to graph this, now you may want to, if you got room, that's great. Me, I'm going to kind of shrink our page, slide him up here out of the way. I'm going to make a graph here, okay? So we got to start at negative 3. That was our beginning, our B. This is equation A. So there's the beginning point. And then our slope was down 3 and over 1. So down 1, 2, 3 more. And over 1. So here is line A, and I'll even label him. There's line A. Alright, so now we go back to the drawing board here. That's A. Now you got to deal with B. So here's equation B. Let's start with him up here. He was 1x plus 2y equals 8. So again, we want to move things around, get the y by itself. So we're going to subtract that 1x over here. Notice here again too, I know I've said it before, but notice I don't line these two guys up. They're not like terms. That's why I kind of shift him over here a little bit. So now we're left with 2y equals a negative 1x plus 8. And now we just divide by 2. 2 is out, and it's y equals a negative 1 half x plus 4. 8 divided by 2 is 4. So now we have our b, which is 4 and our m, which is a negative 1 over 2. Okay, so all we want to do now is, let's again shrink this, throw him up out of the way there. Now we're back to our graph. So b was, right, positive 4 there, okay. So we want to go 1, 2, 3, 4. We're going to do line B in red here. So there's your beginning. And we got to go down 1 and over 2. So down 1 over 2. Our point is going to be here. I think Mr. Brooks made a mistake somewhere. Okay guys, I found my mistake. If we go back here, our slope I said was, yes, negative 3. Yeah, so I told you the slope was negative 3, and in essence I was wrong. It's a positive 3. So I sincerely apologize. So let's go back to the graph on A. Or let's finish B. We can connect these 2 points. This is right. But this, is it going? It's not going to let me erase it. So let me just write this in black. The B is right for equation A, but we should be going up 3 and over 1 this way. Nothing like me screwing up your first video on here, huh? But that's why it can happen. It's easy. Now, as you can see, these two guys cross. Okay, this is the solution that we are looking for, and this is at 2, 3. Okay, so your solution actually for this equation, or this system, is 2, 3. All right. Now you could easily check that by plugging it back into the x and the y for either of these equations, and you should work it out and get the same thing on both sides. Okay? So sorry to confuse you on the first example there, but I'm not going to restart the video just because I goofed on a slope and it doesn't let me change it. So sorry about that. Maybe you caught it as I was doing it, but well, I'm a little slow sometimes. So let's move on to example 2. Okay guys, here in example 2, we got 2 parts of this. It's talking about systems that, yeah, I know, you're loving the lightsaber already, aren't you? I can tell. But systems that have many or no solutions, okay? So we got a couple parts here. We're going to go example A, and your system is going to be 2x minus 1y equals 1. Okay, and then we have negative 4x plus 2y equals negative 2. Alright. Now, what we want to do is, let's get these both into slope-intercept, okay? So, let's take our A equation. Here's A, and here's B. So, with A, I'm going to say, okay, 2x minus 1y equals 1. I'm going to subtract over the 2x, so I got negative 1y equals a negative 2x plus 1. I didn't write that step in. Hopefully you've caught on. Now we divide by negative 1. I will write this one in so that we don't screw up signs like I just did on the last one. So we're left with y equals 2 negatives there make a positive, so it's a positive 2 over 1x. And positive and a negative with a 1 over 1, that's going to be minus 1. So that's your A equation, okay? And let's just try to squeeze in the B right here beside it. Our B is negative 4x plus 2y equals a negative 2. So again, we're going to add that 4x over since he's negative. So now we have 2y equals 4x minus 2. Divide by 2. Again, we'll show that step. So that's out. So we got y equals 4 over 2 reduces to 2, or 2 over 1, x. Negative 2 over positive 2, it's going to be a negative 1. What that here. We got technical difficulty. What do we notice here? They're identical, aren't they? At least I hope you're saying that. If the equations work out to be the same, and if you graphed them, obviously they'd be lying right on top of one another, then this is what we call an infinite amount of solutions. Infinite solutions, okay? Meaning the two lines are on top of one another, meaning all of their points are in common, going on forever and ever and ever. Okay, so if you got the exact same line, like we have here, then it's an infinite amount. Now, let's talk about what if there's no solution. So let's scooch over here just a little bit. Okay, you may need some more room. I'm just going to kind of work off the grid here a little bit. So this is part B of example 2. So we got 1x plus 2y equals 4. And again, that's my A equation. My B equation is going to be 1x plus 2y equals 1. Okay? So now we want to get each of these in slope-intercept form and graph them. Okay? So here's for the A. I'm going to just, so 1x, rewrite it here. Subtract the 1x over, so now you have 2y equals a negative 1x plus 4. Divide by 2, so y is going to equal, since we're getting in the border here, let me write this in blue. So y equals a negative 1 over 2 x plus 2. 4 divided by 2 is 2. So there's your first one. Now let's talk about B. And here's my B equation. 1x plus 2y equals 1. Subtract over the 1x, so now you got 2y equals a negative 1x plus 1. Divide by 2. Y is going to be a negative 1/2 x plus 1/2. Okay, now these obviously don't look the same, do they? But what do we do notice is in common here? Look at the two equations. What's in common? The slopes are the same, aren't they? What do we call lines with the slopes are the same? Hopefully, you're talking about parallel lines. If the lines are parallel, are they ever going to cross? The answer is no. And if that's the case, then this is no solution, because the lines are never going to intersect with one another, because that's what we're looking for in all of these systems of equations. As like the first one, we were looking for where did they intersect? Well, they intersected right here at 2.23. Okay. Over here in the A equation, we had an infinite amount because they were the exact same line. But here in this part B, we have parallel lines. So that means there's no solution at all whatsoever. Okay? Hopefully you understand that. Let's take a look at example 3. Okay, gang, actually before we move on exactly to example 3, we got these 3 parts up here. Exactly one solution means that the lines are intersecting, okay, and there's one solution right there where the two lines cross. If you have an infinite amount, that means you've got the exact same line right on top of itself there, okay? So that means they would go on, there's, an unlimited amount of solutions. Where now in the last one, no solution means that they are parallel lines and they're never going to intersect, and that's what we just talked about. Now, example 3, we're talking about a word problem. It says you're planning to play soccer in 2 different leagues this summer. The first league costs you $40 to join, $5 in for each game you play. The second league is $10 for each game you play. You played a total of 16 games, and it's a total of $160. So how many games did you play in each league? Okay, so we got to figure out a system of equations here, and this is where it can be tricky to set up. Okay, let's talk about the first league, and we'll call him equation A. All right. Now you can see up here it was $40 to join, and then $5 for each game. So basically, think of it that 40. Okay, that is your base. That is our ending number there. Something's going to equal $40. Okay, or I'm sorry. Let's scratch that. Scratch that. Okay, guys. Here's basically what happened. I started looking at this example, and I'm like, I'm not feeling it. Something didn't seem right. So I talked to Mr. Houston. We're just going to scrap example 3 for now, and we'll talk about this in class. But the biggest thing is to understand that with systems of equations, we're looking for a solution, like we had talked about here, which is where do the two lines cross? Is it once? Is it an infinite amount of times, or do they never cross? All right, and it's about manipulating the equations and moving everything around like we were doing in example 1 and 2, okay? So this was probably the worst video I've made all year, and unfortunately it's your very first one for us flipping the classroom, but they'll be better, and hopefully not as long. This one ran a little long, but at any rate, you get the idea. This is how your homework's going to be a lot of times. You watch a video, and you write what I write, as long as I don't screw it up. Have a great day, guys.